You paste a massive codebase into Claude. You hit enter. 10 seconds later, it spits out 500 lines of code. It looks like absolute magic. Beat. Until you actually run it.
Right, and your application completely crashes.
We have all been there, honestly. You are using the smartest model on Earth. So why is the code garbage?
Well, the secret isn't writing a better prompt.
No, it is the system around the prompt.
Exactly. Generating text quickly doesn't guarantee good architecture. You have to stop treating the AI like a magical slot machine.
Welcome to the deep dive. Okay, let's unpack this. Today, we are exploring a playbook of 12 distinct habits for professional AI engineering.
Yeah, a strong, deliberate system turns a basic prompt into production-ready code.
We're going to start by laying a clean, solid foundation. Then we will move into planning and building out the code. And finally, we will explore some advanced parallel workflows.
These aren't just minor workflow tweaks either. These setups fundamentally change how you ship software.
Let's start with the foundation. You simply can't write good code if the AI lacks context.
No, it has to understand your specific coding environment completely.
Yeah, and the easiest way to establish that is initializing your workspace. Before you start chatting, you run a command called /init.
Right. When you do that, the AI scans your local code base. It then creates a small markdown file called CLAUDE.md.
Think of this file as a short project briefing. It captures your overall project structure and your technology stack.
It lists the main folders and your specific coding conventions.
So you skip the painful introduction phase forever. You don't have to explain your project rules every single time.
Yeah, the AI just reads the file and instantly knows the rules.
But you really need to keep this file incredibly short. You want to aim for roughly 150 lines.
Definitely. This file loads into every single session you start automatically. That means it costs you tokens every single time you chat.
Tokens, which are just the basic data units the AI processes.
Right. You pay for those tokens on every single reply. So a massive briefing file drains your wallet incredibly fast.
You should set up a status line to monitor those costs. Use the /status line command to track your context percentage.
You can literally watch that percentage climb in real time.
Seeing that number physically climb trains you to keep sessions clean.
Which brings us to the most common mistake developers make. People love to paste their entire code base directly into the chat.
Oh yeah, they think a bigger context window will yield much smarter answers.
It sounds completely logical on the surface, but in practice, it works the exact opposite way.
When you dump 50 unrelated files into the chat, things break. The context window, the AI's short-term memory during a chat, gets overwhelmed.
Totally overwhelmed.
Think of a bloated context window like a cluttered physical desk. If there's too much junk, you cannot find the stapler.
Right. Under the hood, the AI relies on attention mechanisms. It assigns a mathematical weight to every single word you provide.
If you feed it too much noise, the weights get diluted. Important details simply get buried under all the irrelevant boilerplate code.
Exactly. The AI's attention is pulled away from what actually matters.
The final output becomes incredibly vague and generally unhelpful. So before you send a prompt, ask yourself a simple question. Would a new engineer need this file to do this task?
If the answer is no, the file stays out. Beat. But realistically, sessions do inevitably get heavy over time anyway.
Yeah, back and forth debugging, and the history just piles up.
That is why session cleaning tools are so critical here. When a session feels sluggish, run the /context command.
It shows a complete breakdown of what is actually using tokens.
You stop guessing what is bloating your session. You might see an MCP server eating 30% of your window.
An MCP server, a tool connecting the AI to external data.
Exactly. Or you might see an old irrelevant error log. Once you see the breakdown, you can cut the noise immediately.
Around the 60% mark, you run the /compact command. This command compresses the conversation history effectively.
It keeps the actual meaning while dropping the messy back and forth chat.
You can even tell it exactly what to keep during compression. Like, you can ask it to preserve specific database schema decisions.
Right. Then there is the nuclear option, the /clear command. You use this when you switch to a completely new task.
It wipes the chat history entirely, but your project files stay.
You aren't starting from absolute zero. You are starting fresh with all your long-term project context preserved.
Beat. So how quickly does token bloat actually degrade the AI's logic?
It happens surprisingly fast in complex projects. More noise means important details simply get buried and lost.
So bloated sessions just waste your money and confuse the AI.
Yeah, pretty much.
Now that our workspace is clean, we need some actual direction. If a bloated session is the first way we sabotage AI.
The second is letting it run loose without a clear map.
Right. How do we put guardrails on it?
Well, you always start your workflow in plan mode.
In plan mode, the AI can read, search, and research deeply.
Yeah.
But it absolutely cannot edit your actual files.
It gives you a detailed plan before changing any code whatsoever. It lists the steps and the exact files it will touch.
Importantly, it also lists the assumptions it is currently making.
You read that plan and decide if it makes logical sense.
Let's say you ask it to build a user login page. The plan might say it will use email and password authentication.
But you actually wanted a Google single sign-on flow?
Catching that in plan mode takes about 10 seconds of reading. If you didn't use plan mode, the AI would just build it.
Then you'd have to untangle hundreds of lines of useless code.
The time spent reviewing a plan is incredibly short. It is dramatically shorter than cleaning up a confident wrong agent.
You want to watch the plan for a few specific things. Is it actually solving the right problem?
Is it touching files that should clearly stay completely untouched? Is it making an assumption that violates your core architecture?
When you spot those issues, you push back inside plan mode. You add the missing context and correct the bad assumption directly.
Then you simply ask the AI for a revised plan.
This requires a shift in how we actually view the tool. We have to treat the AI like a fast, capable junior developer.
It is incredibly smart, but entirely new to your company's conventions.
Right. If you tell a junior developer to write a function blindly,
You get raw code that might completely ignore your security standards.
exactly. But if you give them constraints and trade-offs, the dynamic changes. You ask for different approaches, and you make them reason first.
You see their thinking process, and you catch logical flaws early.
You should give the AI complex problems to think about. Ask it to propose 3 architectural approaches with pros and cons.
You read the approaches, pick one, and then ask it to build. 2-sec silence. I mean, I still wrestle with prompt drift myself, honestly.
Oh, really?
Yeah, I constantly want to treat AI like a magic wand instead of a junior dev. It's kind of hard to break that habit.
No, we all do it when a deadline is approaching fast. But there is an ultimate safety net for this exact problem.
It is called the 95% confidence workflow.
Yeah. At the start of a massive task, you add one line. You literally tell the AI to ask you clarifying questions first.
It must ask questions until it is 95% confident.
Right, and it actually stops to ask about weird edge cases. It asks about missing database tables and unverified API assumptions.
You answer the questions, and now your mental models are aligned.
Most bad output comes from confident guessing on vague, poorly defined tasks. This workflow gives the AI explicit permission to slow down.
You align once, you build once, and it usually works perfectly. Beat. But does spending time answering the AI's questions up front slow down the actual building process?
It actually speeds up the total timeline significantly. It cuts 3 or 4 painful rebuild cycles down to just 1.
Right. A few minutes planning saves hours of painful bug fixing.
Exactly. It's an incredibly high return investment.
So the AI planned the feature, and it wrote the code.
Yeah.
But we certainly cannot just blindly trust it. We need the AI to rigorously verify its own work.
You have to add self-checking steps to every single workflow. Do not bolt verification on at the very end as an afterthought.
Bake the check step directly into the AI's initial plan. Tell it to build a payment form, then immediately check it.
Tell it to add the API route, then rigorously test it.
You can use powerful visual tools for this verification process now. The AI can take a screenshot of a locally running page.
It looks at the image to find layout and UI spacing issues.
But the Chrome DevTools integration is where it gets absolutely crazy. The AI can literally open the page and click through it.
It can fill out forms and submit them like a human user.
Under the hood, it's actually interacting with the document object model. It watches the browser console for JavaScript errors as it clicks.
Right, and it monitors the network tab to ensure the API payloads are correct.
This moves the check from surface-level visual matching to structural verification. It changes the question from does it look right to does it actually work?
Once you verify the code works, you want to systematize things. You need to start building reusable custom skills.
Because once you write the same complex instructions twice, you should stop. You turn those instructions into a permanent, reusable skill.
Skills live in a dedicated hidden folder as small markdown files. Each file represents a highly specific, repeatable workflow for your project.
You might have a skill file just for standard code reviews. You might have one that scans the code base for massive technical debt.
You write the workflow once, and you can call it anytime.
Building custom skills is like stacking Lego blocks of data. You build it once and reuse it forever.
This is where the tool stops feeling like a simple chat box. Your repeated manual work becomes named, versioned, improvable engineering assets.
And you commit these skill files directly into your Git repository.
So when a new developer joins, they clone the repository, they immediately inherit all of your AI workflows on day one.
What actually shifts when you transition from chatting with an AI to building an actual system?
It changes how your entire team operates fundamentally. Named, version skills turn raw chats into improvable team assets.
Commit the skills file, and your whole team instantly levels up.
Sponsor.
Okay, so standard tools sometimes hit their absolute limits. What happens when you face massive multi-part problems at scale?
You have to scale your workflows horizontally across multiple models. You introduce subagents for handling parallel, highly complex tasks.
A subagent, a secondary AI session handling a specific task. Your main session stays on the incredibly powerful Opus model.
But it spawns smaller subagents to do the tedious busy work.
You can spawn several of these subagents all at once dynamically. One agent reads through 500 pages of complex Stripe API documentation.
Another agent scans your entire code base for similar architectural routing patterns. A third agent starts writing the rough first draft of the code.
They work completely in parallel and then report back to the main agent. They provide short, dense summaries of their findings to the Opus model.
Your main session stays completely clean and incredibly light on tokens. You save the heavy Opus model for the hardest reasoning tasks.
You use the cheaper, faster Haiku model for the reading agents. It is incredibly efficient from a cost and time perspective.
Whoa! I mean, imagine spinning up parallel agents to research and test while you just sit back and think.
It is wild.
If we connect this to the bigger picture, it's crazy. You are essentially managing a digital development team.
But there is a very real, very dangerous problem here. Parallel sessions will absolutely overwrite each other's files if left unchecked.
Oh, definitely. Think of it like two chefs trying to bake different cakes in the exact same mixing bowl.
If you have two sessions in the same folder, they fight. One agent edits a core file, and the other instantly overwrites it.
You end up debugging a massive mess that nobody actually wrote.
You need Git work trees to manage this chaos effectively. A Git work tree links a directory to a specific code branch.
Normally, you switch branches inside a single project folder, but work trees give each parallel session its own isolated directory on your hard drive.
They are in the same repository, but in completely separate physical spaces. You can run one session building a new feature entirely.
And you run another session on a stubborn bug fix in another directory?
They all run at once, with absolutely no file conflicts. The AI agents are completely blind to each other's experimental changes.
When a task is fully verified and done, you just merge the branch back.
For a solo builder, this is truly revolutionary software engineering. It's kind of like cloning yourself 3 times over.
It really is.
A beat. But how do you definitively prevent these multiple AI agents from destroying each other's code?
You have to isolate their environments completely from the start. Git work trees keep them in separate spaces until you're ready to merge.
Git work trees keep every agent safely inside its own sandbox.
Right, they can break things in isolation without ruining production.
We have scaled wide, so now let's scale deep. How do we handle impossibly hard bugs and long-running, tedious tasks?
You start using hooks and loops for deep, continuous automation. Once you have parallel sessions running, you have to stop babysitting the terminal.
Hooks trigger a notification when a specific event finally happens. You can get a desktop ping when a massive test suite finishes.
Then there is the loop command, which is basically an infinite worker. It lets a session rerun a prompt on a continuous schedule.
You can have it check your server deployment status automatically every 5 minutes.
The best part is the session actually keeps its memory intact. It maintains context across those continuous loops for up to 3 days.
It remembers what failed 10 minutes ago and adapts its next check.
But this raises an important question about resource allocation. What happens when standard, fast reasoning just isn't enough to solve the bug?
Here's where it gets really interesting. We bring in the heavy hitter. It is a feature called UltraThink.
UltraThink tells the AI to use its absolute maximum thinking budget. It uses up to 32,000 tokens just for deep internal reasoning.
The AI essentially argues with itself before typing a single word of code.
Under the hood, it's exploring a path, realizing it's wrong, and backtracking.
It is the fundamental difference between a shallow answer and a profound architecture choice. You use it for deep debugging on problems you've already failed to solve.
You use it for massive, risky refactors where one wrong call breaks the entire application.
But why shouldn't we just use UltraThink for every single prompt to get perfect code?
Because it is incredibly slow and highly expensive to run, routine work simply does not need a massive reasoning budget to succeed.
Save the heavy UltraThink budget only for the hardest architectural problems.
Yeah, if you are just centering a div, you don't need a supercomputer pondering the universe.
Exactly.
Beat. But seriously, we suggest picking just 3 of these habits to start with today. Try the init command to build a tight Claude..md file.
Use plan mode on absolutely every new task you tackle.
And bake a self-check step into every to-do list you write.
So what does this all mean for us? Let's synthesize the main theme of this entire playbook.
Modern AI heavily rewards the person who actively designs the workflow.
It does not reward the person writing the cleverest single prompt anymore.
The structural system you build matters exponentially more than the initial command you type.
2-sec silence. Think about this for a moment. An AI can plan its own execution completely from scratch.
It can visually check its own UI with developer tools.
It can loop its own monitoring workflows autonomously for days. Beat. What does the future role of a human developer actually look like?
Are we moving away from writing code line by line?
Are we simply orchestrating a team of digital minds to build our visions?
That is a profound question to walk away with today.
Thank you for joining us on this deep dive. We highly encourage you to test out the init command on your very next project. Outro music.